Hi everyone. Today we're starting on page 8 of your notes and we're looking at molecular formula. So last lesson we looked at empirical formula and today we're looking at molecular formula, which is the reality of the molecule. So your definition that you need to write in is here on the slide. It's a formula which shows the actual number of atoms of each element in a molecule. So remember, learn that off word for word, and molecular formula then is the actual formula of the molecule, how we find it in nature. Just below where you've written your definition, hopefully you paused the video to get that written in, we have a table. And in the table, you've got the compound name. And what I've given you already is the empirical formula. So take a minute now, pause, and then write down your empirical formula for each of these compounds. Remember, the empirical formula tells us the simplest ratio of atoms in a molecule. So this is the simplest ratio that we're looking at. You'll notice that the simplest ratio means it sometimes is going to be the same as the molecular formula. The likes of water there, H2O, you're familiar with that. But the likes of ethane, hopefully you can already tell, CH3, that's not the formula you would use for ethane. So that's the simplest formula. What we're going to do now is we're going to write down the molecular formula. Sometimes it will be the same, and then sometimes it will be different because it was able to be simplified for the empirical formula. The molecular formula then for water is H2O, the same as the empirical. Carbon dioxide is CO2, so it's another that's the same. Ethane is C2H6. Ethene, C2H4. Hydrogen peroxide, H2O2. Chlorine is Cl2, it's diatomic, doesn't exist alone. Ammonia, NH3. Aluminium chloride, Al2Cl6. And sulfur actually exists as S8. So this is where you can see that they would be able to ask you questions maybe for a compound, asking you both for the empirical formula and for the molecular formula. They could test both things here. Now, we did study calculating molecular formula last year. So again, this is just another recap. So these are your steps. The first thing you need to do is write down the empirical formula. And from yesterday's lesson, you should be able to do that. Then you need to calculate the MR of the empirical formula. So what's the total of the mass numbers in that empirical formula? Then what you want to do is take the actual MR of the molecule. So in the question, they will tell you the MR of a molecule is whatever. So take that, divide that by the MR that you've found for the empirical formula, and then whatever you get that number to be, you need to multiply the empirical formula by that, and that will get you your molecular formula. So we're going to look at a few examples just below that, still on page 8, and then moving on to page 9. So if you go to page 8, you'll see the start of some of the examples here, and it goes on to page 9 as well. So we're going to look at the first one there. So the first thing we've been given is the empirical formula. And for the first one there, it's CH2O. Then what you normally have to do is you've got to calculate the MR of the empirical formula. Now this has been done for us. It's described as mass of EF there in that column. But if you were doing it without this example, remember you just look at the mass number of each of the elements here and how many you have. So you've got one carbon with a mass number of 12, two hydrogens with a mass number of 1, and one oxygen with a mass number of 16. So add that all together and that gets you 30. Then your next step is to take the actual MR. You will be given this in the question. You will be told that the MR of a molecule or the MR of a compound is blah, blah, blah. And they will tell you what that is. And then you will take that and divide that by your empirical formula MR that you have worked out. So here we've been told the actual MR is 90. So our calculation is 90 divided by 30, and that gets us 3. Then we take our empirical formula and we multiply that then by our answer to the above. So we're going to take CH2O, multiply it by 3. So we put brackets around the empirical formula, put the 3 to the outside to remind us we've got to multiply it, and then it is C3H6O3. And that's your answer to the first example. Now the next and final example that we're looking at is just at the very bottom of page 8. And here we're told the empirical formula is CH3. We then have to calculate the MR of that. Remember, the MR is just looking at the elements that you have, the number of them, and their mass numbers. So we've got one carbon with a mass number of 12, and we've got 3 hydrogens, each with a mass number of 1. So our calculation is 12 plus 3 gets 15. So the MR of the empirical formula is 15. Then take the actual MR that they have given you, and here they've told you it's 30, and divide that by the MR of the empirical formula. So the calculation is 30 divided by 15 gets you 2. And then the final step is take the empirical formula and multiply it by that number you've just found. So here we've taken CH3, multiplied it by 2, and that gets us C2H6. Now we've done those 2 examples, what I want you to do is work through then the questions on page 9. So it's just following the same format, and you're going down to just about halfway down through the page where the last example is you're working with phosphorus P. Once you've done those questions, we are moving on, but I will want them uploaded then to Google Classroom for me to check them. Follow the steps we've done before, lay it out exactly as before, and I'm sure you'll get them all right. Now, once you've finished those questions on page 9, make sure you pause the video there and you completed them before you move on. You can see just below halfway down page 9, we're often asked to calculate molecular formula by doing 2 steps in the exam. The first thing is to work out the empirical formula. So they like to incorporate these 2 things in. So they want you to work out the empirical formula first, and then you've got to do what we were just doing there on page 9, comparing this mass to the MR to work out the molecular formula. So we're going to look at an example just at the bottom of the page here. So our example says, an organic compound X contains 0.3 grams of carbon, 0.05 grams of hydrogen, and 0.08 grams of oxygen. From the mass spectrum, the molecular mass is known to be 172. Work out the molecular formula of this compound. Now, the first thing we will do then is we will write down this table, or just kind of the general format here to make your life easier. So I've got carbon, hydrogen, and oxygen in my top row, and I'm going to write down the mass of them next. So the question tells me I've got 0.3 grams of carbon, 0.05 grams of hydrogen, and 0.08 grams of oxygen. We're working out the empirical formula here. So the next step we're going to do is we're going to calculate the moles. So take this mass and divide it by the AR of the element. So the moles of carbon is 0.3 divided by 12, and that gets you 0.025. For hydrogen, it's 0.05 divided by 1, gets you 0.05, and then 0.08 for oxygen divided by 16 gets us 0.005. Now remember, to calculate our ratio, we divide these moles through by the smallest mole number there. And the smallest one there is 0.005. So for carbon, our calculation is 0.025 divided by 0.005, and that gets you 5. Then for hydrogen, it's 0.05 divided by 0.005, gets you an answer of 10. And then for oxygen, 0.005 divided by itself gets you an answer of 1. So your empirical formula, as you can see there at the bottom, is C5H10O. So that's the first step done. Then we're going to move on and we're going to look at calculating molecular formula as we've done before. So we have our empirical formula written down. What we then need to do is work out the MR of the empirical formula. And how we do that is, well, we've got 5 carbons, so 5 12s, plus 10 hydrogens, so 10 1s, plus 1 oxygen, so 16. So 5 12s plus 10 plus 16 gets us an empirical formula of 86. Your next step then, remember, is to take your actual MR and divide that by your empirical formula MR. So 172 divided by 86. Okay, now I am showing this in this slide laid out the way we've done it before. So we had our empirical formula there. We calculated the MR of the empirical formula, so all that I've explained there. And now we're going 172 divided by 86, and that gets us 2. Multiply your empirical formula by the answer of the above calculation, and you should get C10 H20O2. So follow those 2 wee slides there, write down all you're working out in that space, and that's how you would do that. Taking these 2 ideas that we've learnt in these 2 lessons and putting them together. Calculate your empirical formula first, just as you would have done in the previous lesson, and then calculate your molecular formula using that information. So not too hard to do at all. Now, to finish off today, then, you just have to complete the questions on page 10 and 11, practicing this. So we should be really confident by the end of this today on calculating empirical formula and molecular formula, and often doing it within the one question. Now, once you're finished that, you're going to upload that to Google Classroom. So you're uploading page 9, page 10, and page 11. Upload it as either a PDF or as pictures on a Google Doc, whichever's handiest for you. Okay, if there's any issues, don't be afraid to get in touch, but that should be handy enough because again, it's just revision of GCSE.